Welcome back, Chappelle. Welcome back to it. Welcome back to your flipped classroom since Christmas break, right? I hope y'all had a fantastic break. I welcome y'all back to your flipped classroom where we're going to pick up our discussion where we left off in class talking about the scientific revolution, right? We watched Mr. Terry dork out, geek out about space for probably at least 10 solid minutes. You know what I mean? At least, you have to understand, again, if I could teach anything else, I would teach science, right? And I love talking about the scientific revolution, right? I love freaking kids out like Blythe, where we talked about in class during E period about how, the space is nothingness forever, right? I love talking about it with kids in B period and stuff like that as well. I love talking to, yelling at Jalen Klein that if we just, took her and put her in a spacesuit and just shoved her out into space, she'd just float for forever, right? So the big thing that we need to understand, though, is we're going to pick up right where we left off in class, talking about our changing views of the universe during the 1500s, right? So just we could actually wrap the entire thing together so we understand a little bit better. All of this is happening during the 15 going into the 1600s, right? So while you've got events in the Americas going on, like Cortez taking over the Aztecs and Pizarro battling Atahualpa at the Battle of Cajamarca, right? Where you got Europe expanding, when you have the Reformation kind of going on at the exact, not even kind of going on, very much going on at the exact same time, you also had the scientific revolution truly beginning under Nicholas Copernicus, right? And we talked about that in class, talking about this guy, this Polish scientist in the 1500s, is going to publish a book called De Rev, right? And he's going to do that in the 1540s, right? So De Rev, Copernicus is going to, let's see when he actually did that, just to be safe. He does it in 1543 is when that book comes out. Man, 1540s, look at me go. So the big thing about it is he publishes De Rev, which is the very first book to actually advocate for a heliocentric model of the universe, right? And that heliocentric model included the idea that was brain-breaking to so many that the Earth was actually not the center of the universe, that actually the center of our universe was the sun, and that all the planets actually revolved around it, right? Now, we talked about in class today as well about how the sun isn't necessarily even stationary, how it's actually moving through space, and how our understanding of the universe has grown by leaps and bounds in the last few hundred years. But the thing that we need to understand is, our understanding of the universe is now so big, but the understanding of the universe by the populace of the experts in academia in Europe at the time during the 1500s, when Copernicus comes out with this book, is actually pretty limited, right? Most experts, who are mostly theological scholars, came out with this thing that was oh yeah, well, Copernicus, how are you going to disprove retrograde motion, right? So we talked about this in class as well. Retrograde is the concept or the idea that it looks like some of the planets are moving backwards, right? So most of the experts of the day in the 1500s looked at Copernicus and they were like, big fella, there's no way that we're going around the sun. How could we be going around the sun if you got planets like Mars moving backwards in the sky? Well, look at this graph really quickly, y'all. Mars isn't actually moving backwards. It's the projection of its light. Because Earth is moving faster around the sun than Mars is. Mars is actually going slower. We are observing it from different vantage points. And as we observe it from different vantage points, it projects it further out into space, right? And it looks like it's going backwards, but it actually isn't really. So when you're in college one day and somebody's like, oh, Mercury's in retrograde, I can't start anything new, you can punch them in the face and say that actually this doesn't affect you at all because that is a perceived motion, not a real motion, right? So retrograde motion is this optical illusion that Copernicus died, of course, not even being able to refute because he died and then a couple weeks later, he didn't die and a couple weeks later his book came out. His book came out, De Rev, and then a couple weeks later he dies, right? So his theories kind of sit on the shelf for a little while, right? And then you got people like Pluto getting kicked out of the solar system. Now, the thing, though, that comes along, though, after that, right, is you're going to have another scientist pop up who's going to kind of unintentionally provide the data for actual Copernican theories, right? And his name is Tycho Brahe, right? Tycho Brahe is a Danish scientist, okay, who actually has this crazy little backstory, right? He is actually from Denmark, okay? If he's Danish, he's from Denmark. And he had actually literally been kind of wooed a little bit by the King of Denmark, right? So the King of Denmark didn't want him to go anywhere, right? Everyone knew Tycho Brahe was very, very smart, right? This is him right here looking like a weird Lorax, right? So Tycho Brahe was a very, very phenomenal intellect, a phenomenal scientific and mathematical mind, so much so that he also defended his mathematics very ardently, right? So to give you all a little bit of a fun fact about Tycho Brahe, he actually was missing the tip of his nose. This is the prosthetic nose that he would actually wear around everywhere because literally he got into a duel with his cousin and they actually over a math problem and they cut out, his cousin actually cut off the tip of his nose so he would wear this prosthetic around all the time, just like a little fake nose. Now, the Tycho Brahe phenomenal mathematic mind, right? He is going to spend years after the Danish king buys him an entire island, right? The Danish king didn't want him to go to somewhere like the Holy Roman Empire or to France or to some other place where these kings are investing in the scientific revolution and investing money in scientific advance. And so instead, the king of Denmark is like, look, here, have an island. How about that? Have an island where I'm going to give you one island, but one half of the island's going to have a telescope on it. The other half of it's going to have just a mathematical center on it. And so he spent years on this island, provided to him by the Danish king, analyzing the night sky, right? And he would actually look, and we believe he's actually considered one of the last naked eye astronomers, right? So something we need to understand about Tycho Brahe is he did most of his observations just using his eyeballs, right? He did have some rudimentary telescopes and things like that where he would actually observe the stars and stuff. But what he's going to do is he's going to chart the movement and position of over 777 different stars in the solar system and in our observable universe, and he's going to write them all down, right? And those tables that he wrote them down on are known as the Rudolphine tables, right? The position and location and coordinates of multiple different celestial bodies throughout the year of over 777 different individual things. So that's a lot of data that this guy has collected, right? And then on top of everything else, he also observed something phenomenal, right? He saw in the solar system, in the constellation of Cassiopeia, he observed a star being born, right? He observed a star going supernova. That actually, what happens when a star goes supernova? It does it twice in its lifespan. Once when it's being born, right? It actually goes supernova where all the gases are compounding in on each other, and there's actually a massive reaction. And so the thing about it, though, is as that star was being born, he observed it and saw it blaring through the night sky. And he was like, y'all, this undoes everything that Aristotle and Ptolemy and all those guys said about the universe. It's not the beginning of heaven. The things out there are not perfect. Things are blowing up. They're exploding. They're dying. They're moving. They're going through these different processes. So on top of the fact that he collected all that data and also observed a star going supernova, he's going to begin to learn so much about the universe and provide ample amounts of data for the world to actually use. And Tycho Brahe also is very, very important as well, because that data will then be used by his assistant a little bit later on to really, really to actually use the mathematics that are provided to him to figure out what's up with this whole retrograde motion thing. Now, on top of everything else, Tycho Brahe is also a funny character because he actually had a little person that lived under his table as well. His name was Jep. He thought he was psychic. And he also had a pet elk that died falling down the stairs after he got drunk. But we'll talk about that in class a little bit later on. Tycho Brahe is a funny little guy, but this most important thing is all this data that he collected. Well, his assistant is a guy named Johannes Kepler, right? And Johannes Kepler, after Tycho Brahe dies, right, is going to move actually away from Denmark because the prince or the son of that king that gave the island to Tycho Brahe is going to defund the entire program. But he moves over into the Holy Roman Empire, and that's why they're called the Rudolphine tables, because he has them named after the current Holy Roman Emperor. Johannes Kepler, though, is that German assistant to Tycho Brahe, and he takes all of this information, all those mathematics, all that understanding that Tycho Brahe has acquired, and he uses it to prove heliocentrism from a mathematics standpoint, right? He uses all of those numbers to figure out that the orbits of the planets are not necessarily circles, that they're actually oval in shape. And if you compensate for the speed of planetary motion using ovals rather than using circles, you can disprove retrograde motion, right? You can use that to efficiently solve the problem of retrograde motion to explain to somebody that actually we are observing a planet move backwards because of the oval shape and the different variant speeds of those bodies moving towards us or away from us, right? And so this is going to be a very important thing because he also comes up with laws with planetary motion and talks about how as they get closer to bodies, they speed up, right? And we'll talk about that a little bit in class as well. But Johannes Kepler's biggest thing that y'all need to highlight is that he is going to make those orbits, the orbits of the planets, ovals, not circles, right? And so he's going to, of course, do most of this work in 1609. But the big one that you need to remember more than anybody else is probably none other than Galileo, the great combiner of all of the assets of the scientific revolution, right? And this man's full name is Galileo. When you talk about Galileo, it's actually Galileo Galilei, right? And Galileo Galilei is going to be a very important Italian astronomer that is not going to just prove it with math, not take just Copernicus' idea of heliocentrism, but he's going to prove it using technology and the naked eye, right? He's going to use it to the point where he's going to be actually showing people heliocentrism in effect, not just kind of talking about it, right? So he is an Italian scientist that is going to prove that heliocentric design, right? And he does most of this by using this device that he reinvents, kind of, right? Now, first of all, just so you understand, he's using a telescope, right? Now, he didn't invent the telescope. A lot of people will tell you he invented the telescope. He actually did not. A Dutch scientist invented the telescope first. He just came along and perfected it. He added multiple refracting lenses onto the inside of it so he could see even further, right? Now, the funny little thing about it, though, is he actually didn't even design it to look at the stars. He actually originally designed it for Italian merchants in Venice so they could see ships coming in over the harbor, or excuse me, over the horizon, so they knew when their shipments were coming in. But one day he takes this design that he's creating and he just looks up towards the sky with it, and he begins to document the things that he sees. And the things that he sees in this is he uses a telescope to analyze things like comets, the moon, the moons of Jupiter, and other moving bodies that are like swirling around throughout the universe, right? And he realizes something very, very important. He realizes that size relates to the actual movement of heavenly bodies, right? That smaller things go around bigger things, right? That our moon is much smaller than we are, and so it is a satellite caught in our orbit, and it moves around us. He observed the moons of Jupiter and realized that Jupiter has multiple different moons, and that they're actually moving around Jupiter as well. It has 8 total moons in total, which is crazy. One of its moons is actually the size of Earth. It's called Titan, right? So now he's also going to look at the surface of the moon and realize that it's not a perfect sphere. It's blotched with comets and craters and other things like that, which are smaller than the moon, which got caught in its pull and pulled it inside of the moon's orbit as well. So when we use this, and he uses mathematics to prove it, he has a eureka moment, and he's like, not only am I using math, but I'm also using observation to prove heliocentrism is real, right? And so what's going to end up happening, though, is he wants to release these findings, right? Now, who does he need to make sure he doesn't make upset? That's exactly right. The church, right? He needs to make sure he doesn't make the church too upset. Well, the sitting pope at the time, that you need to go ahead and write his name down, is a man by the name of Urban VIII, right? Urban VIII was a sitting pope at the time who actually knew Galileo. They had conversations with each other. They knew each other pretty well, right? They would actually consider themselves friends, right? Urban VIII was a little bit of an odd character, though. Urban VIII was very progressive. He was very, very intense. He outlawed sneezing in the Vatican for a while, which was funny because he thought it felt too good, and he was like, sneezing feels too good. Don't do it in my presence. And for over 100 years, you could sneeze in the Vatican because of him. But him and Galileo had a conversation. Galileo was like, big fella, Urban VIII, I think you do, Urban, can I call you Urban? He goes up to him and he's like, I don't think you understand. Yo, this whole thing that we live inside of, we're going around the sun. And Urban stops him and he's like Galileo, big fella, we know. And he was like, what, you knew? And then apparently Urban knew the entire time that we go around the sun. But the problem is that Europe was embroiled in a huge war at the time. It was called the 30 Years' War, where Catholic armies were going against Protestant armies, and he really couldn't just have that on his hands for have somebody be like, oh, by the way, a bunch of stuff the Bible says is wrong. He couldn't really have scientists coming out left and right, driving more people towards the Protestant side. So Urban VIII goes up to him and says, look, I know you're a good guy. I know you wrote that pamphlet about me. This is the pamphlet that he actually wrote about him. It's called The Assayer. It's about the movement of a certain comet, and he dedicated it to Urban VIII. Galileo did. And he's like, I appreciate all that stuff you did, but I can't just have you releasing all these findings. You need to release necessarily your findings, but then also talk about what the church believes as well. And Galileo takes the task. He's like, okay, I can do that. And Galileo writes a book, right? And he writes a book called The Dialogue on the Two Chief World Systems. And he released it in 1632 when Europe is in the middle of this really chaotic war. The most life-changing war that ever had actually happened in European history up to that point. Claimed the lives of over 3 million people, right? And in his text was called A Dialogue of the Two Chief World Systems. He writes this story, and he does a big screw-up thing, and it ends up landing him in hot water, right? It lands him in hot water because he manages to make Urban really, really upset. He actually writes the story as if there are 3 guys at a bar, right? And one guy is in the middle who is being convinced by the other 2 guys about which system of the universe actually makes more sense, right? And the one that represents Galileo's ideas of heliocentrism is smart, suave, debonair, makes a lot of sense, does a really good job explaining his entire content, and he actually does it in a convincing manner. The other one that represents the Catholic Church point of view is named Simplicio, which actually means idiot or simple-minded in Latin, right? And so literally he sounds kind of all over the place, talks about the Bible constantly and stuff like that, and Galileo kind of paints him as a stooge or as somebody who is dumb. And so Urban VIII goes like, bro, why would you do this? And he gets super upset at Galileo, and so does the church. So Galileo gets put on trial by an inquisition for his crimes against the church, for embarrassing them during the middle of this war, and for trying to make them look silly for believing that the earth actually was the center of the universe, right? He gets put on trial by an inquisition, and the inquisition tells him, we will burn you at the stake, or you can take back all the things you said. And unfortunately, Galileo was forced to take back the things that he said. And then they placed him under house arrest for the rest of his life, right? He would be tried in front of an inquisition for heresy, forced to recant his ideas, and he spent the rest of his life under house arrest, right? Spent the rest of his life under house arrest, where he also came up with a lot of different theories as well. For example, while under house arrest, Galileo came up with a theory, and they actually proved the fact that all bodies moving towards the Earth fall at the same speed. He claimed that actually, like, he did this off the Leaning Tower of Pisa, which is actually not true. But if I drop this football and my keys at the same time, they're both going to hit the ground at the exact same time. He figured that out while he was under house arrest and actually wrote a lot of those theories down while he was doing that. He came up with the first opinions and theories on satellites while he was under house arrest, but he lived for the rest of his life in a small little apartment above a street level alley where he had to sit there, and like that's where he lived for the rest of his life because he actually lashed out against the Catholic Church. But we do know that he was correct, and we have a little bit of his body left around. Actually, funny little fact I love about Galileo is his middle finger is in a jar in Italy, right? Because somebody dug up his dead body in the 1700s and pulled the middle finger off of his dead body and stole it, right? And it's now been recovered, and it's in a jar in Italy, in Florence, right? In the National Academy of Sciences Museum, and it's Galileo's middle finger, just in a jar. And I think it's hilarious, because, like, it's like he's flipping off the world for the rest of eternity, being like, I told you I was right. You know what I mean? Like, so, the big thing about when we're looking at this, though, it's a very, very fun little fact, right? So, going into it, you have to understand, though, is on top of everything else, we now know, because of astronomers like Galileo, Kepler, also of Copernicus and people like that as well, that the Earth actually goes around the sun from their theories and modalities. And Galileo comes along and proves it. Now, another big advent of the scientific revolution is going to be a culture change, right? These astronomers are going to cause a massive shift in the thinking and understanding of the world around us, right? And it's going to move in the direction of a new scientific method, right? So because of all of these discoveries of people like Galileo, of other ones like Niels Bohr, and other scientists that are coming around at this time, it leads to the creation of this thing known as the scientific method, right? And the scientific method is an idea where we use a series of steps to analyze or solve a scientific question, right? We have a problem, we create a hypothesis, we design an experiment, we observe the results, and then we come up with a conclusion, right? And the thing about it, though, is that scientific method is oftentimes attributed to one particular thinker, right? This whole thing that you have to learn every single year when you're in high school is usually attributed to the ideas of observation, and it kind of goes away from church law and assumption. The guy that actually apparently came up with it is a man by the name of Francis Bacon, right? Like, so now Francis Bacon, all right, an English thinker, kind of is the very first person to really write it down, right? He was actually a member of parliament inside of the Stuart monarchy parliament, and he used observation to prove many problems. He wrote a very famous book called New Atlantis, where he actually discussed the ideas of the scientific method and talked about how we needed to use the scientific method to solve modern-day problems. And then the other big one as well is you're going to have this other guy named Rene Descartes, who's going to believe in using human reasoning to solve problems and diminish doubt. But we're going to start our next class right here and talk about Francis Bacon and Descartes, and we're actually going to move forward talking about the scientific revolution and wrap that whole thing up in class. But I'll see y'all then. Y'all